Hello everyone, and welcome back to another episode of Solidity Fridays. Today we are joined by Jeffrey from RareSkills, and we will be talking about advanced developer education.
Hi, I'm Jeffrey. Let me just start by really quickly introducing the RareSkills. Most people know of it as a website which holds a bunch of content, which is pretty accurate. So I'm starting to share the screen now. Hopefully it's visible. And one thing I think that really sets us apart as an education company is we really try to service the advanced developers. There's a lot of beginner tutorials out there, which is awesome, but I think the advanced market is very underserved. So our audience includes auditors at OpenZeppelin, Spearbit, and we've had protocol leads at different companies that you've definitely heard of and probably use, either take our courses or engage with our tutorials. So in terms of we do two things. One is we do instructor-led learning, and we also do free content. So instructor-led learning is paid because we have to pay the instructor, but these are the three topics that we sometimes do. Instructor-led learning, which is online, but with a human, very experienced one. And otherwise, we publish content which is free and requires no email or anything to use. So for example, our most used resource is the RareSkills Book of Zero Knowledge. We call it RareSkills ZK book.
These books are amazing.
Change
I love this one.
Oh, thank you. Yeah, so what we were not the first people to try to explain zero knowledge proofs. They were definitely notorious for being very hard to understand. And they were. It took me a year of on and off just to understand what was going on. But what we ended up doing, I think that really made this our most successful work, is we figured out there's definitely math involved in zero knowledge. You cannot get away from that. But you don't need to have the equivalent of two senior level math courses under your belt to understand everything. You can do the minimum math required. That's how we would go about it. How can we set a foundation, teaching as little math as possible, but not skipping it? And these are the topics that we ended up seeing were the foundations of math. And from there, it can be evolved into understanding. Okay, once you understand the building blocks, you can just wire it together and turn it into, say, the Groth 16 algorithm or bulletproofs, which is what Zcash. So the Groth 16 algorithm was the first iteration used by Zcash. It's also used by Tornado Cash and some versions of Semaphore. The other stuff that the privacy scaling explorations and at Ethereum Foundation maintains. And bulletproofs is used by Monero, Mina, and Zcash. They're in their Halo 2 implementation. So
I love Halo 2.
I'm sorry?
I love Halo 2. It's really, really good.
Yeah, so that's for the Zcash Halo 2 library, they use bulletproofs as the polynomial commitment scheme. So the other thing that's the second most used thing is 60 Days of Solana. So this is an introduction to Solana, but like I said, we really target the advanced market. So the kind of the thesis of this course was if you all, let's say a developer is starting from nothing and they decide to learn Android development, they have to figure out, okay, is the framework, how are these mobile frameworks generally architected? Whereas someone who already knows how to program an iPhone should be able to pick up programming Android pretty fast, relatively, right? Because they can reuse a lot of concepts. So we taught the Solana course from the angle of, hey, you're used to thinking in terms of message sender and storage and message.value and stuff like that. So how can we reuse some of your existing knowledge to understand what Solana does? Because all these blockchains in their marketing, they like to say we're different, we have a different architecture, but it's a distributed state machine that you update with paid transactions. Like it's the same thing at the end of the day. Uh-oh.
Oh, I can hear you again.
Yeah, we can hear you just fine.
Sorry, it seems like the cable disconnected from the microphone and then it disabled the audio. All right, trying again. Right, so that's the knowledge that you have in common if you already have a lot of experience teaching. If you already have a lot of experience programming on Ethereum, then you can reuse a lot of that to do Solana. I'm fairly confident over half of the auditors in the Solana ecosystem came through this resource. At least that's what I've had a lot of private conversations about that, and a lot of the projects that people have heard of, like, well, I can't name the specifics, but the stuff that's quite famous, people onboarded through this thing. So that's something we're very proud of. I mean, the popularity wasn't entirely inside of our control. When the price shot up, then the resource became very popular. So back when Solana rocketed from like $20 to $200 or something like that. So here's the other stuff that we have. I guess what we're not showing here right now is we're building out a resource on Uniswap v3 also. So one thing that we really like to do is code-based walkthroughs of the most forked protocols. So Uniswap v2 is the most forked protocol. Compound is heavily forked. Aave is heavily forked. Uniswap v3 is heavily forked. So if you understand how those work, then you can learn how to audit the forks or build a fork or take inspiration from their concepts. Or you can learn what are the implications of how I choose to integrate with them, because a lot of security issues or whatever come from bad integrations. So that's we really feel like if you know this knowledge, it's going to help you with a lot of other things. So that's so the best way to obtain it without this resource is just to read the code base. So we're trying to think, okay, if the benchmark is reading the code base, how can we make that process faster just by explaining the right things so you know where to start and can bootstrap your knowledge a little bit more easier. That's really what that's really the value that we try to provide for people, because like I said, we target advanced people who could figure it out on their own anyway. But if we can save them 10 hours, 50 hours, 100 hours on trying to figure something out, then that actually leads to a lot of impact because they're not bogged down with trying to onboard. What we really want is people not to be spending a ton of time on our platform. I mean, we do, but the end goal is that they get what they need and then they're able to audit or code out what they need to. So yeah, that's pretty much RareSkills in a nutshell. We're more or less a content company with some, we fund ourselves through paid trainings and also recruitment. So Rare Talent is our recruitment company. So plug if you're looking for work or hiring, check it out. And we're very affordable, by the way, for people who are hiring, because our rates are probably the lowest in the industry at 8%. So aside from that, we've sometimes, the Solana paid for the content on the website, so they funded that. So we have done some content partnerships with other protocols. And I think with that is what I can wrap up what RareSkill does.
Awesome, thank you. That's really interesting. You guys do so much for the community and for other devs. It's amazing. Thank you.
Thank you.
So we were going to talk a bit about developer education today. Are there any topics you want to cover there?
Yeah. Well, is there any aspect of it you're curious about? I can give you a rundown about how we approach it if you're interested.
Yeah, let's start there.
What our philosophy is. All right, sure. So probably the big one, if you're writing a beginner tutorial, it's easy and difficult at the same time. It's easy because there's a lot of other people who've done it, so it's very easy to learn the subject. But if you are just rehashing what other people have written, then your take needs to either be really, really good, or it's just going to get drowned out. And I've seen this a million times over. Like, how many articles on reentrancy are there? If someone told me there were 10,000 articles on reentrancy, I wouldn't, and had facts to back that up, I would. That seems plausible. Maybe that's a tad high, but there's a lot.
Yeah.
So,
you're back. That pesky cable.
Yeah. Sorry, there seems to be some difficulty. Sorry about that. Anyway, so that's beginner tutorials. But the next thing about that is it's very easy to know where the reader's coming from. If you're not sure, you just explain it to them, right? With more advanced readers, now you kind of have to take very educated guesses about what they already know or what they don't. You can explicitly state it, but you can't really say, hey, if I was to describe everything that a Solidity developer with 2 years of production experience has, could you actually write out a list of everything they know? I don't think so. Like some of it's buried in your intuition, so you can't immediately access it. So
it might be different between two developers.
Exactly. So a lot of the first part is figuring out what are we going to assume the reader knows, because it's a very big drag if you explain things that the person already understands. Now, because we interact with a lot of developers through our training program, we do get at least some idea of what people know or don't know already. But I would say that's the first tricky part of writing something that's more advanced, is figuring out what does your audience already know and how can you leverage that, because that's probably that's a very important teaching technique, is relating to what somebody already knows. Because if you tie it, if you're teaching things in isolation and they don't see how it fits into everything that they know already, then they're probably just going to immediately forget about it. So once we have a picture, some idea of what the person already knows, or at least we've made a decently educated guess at the next thing is, it's important to build a knowledge graph of the subject that you're teaching and make sure that, okay, so let's use an example of, let's say we're trying to explain how Aave works, for example, right? So what goes into that? Well, one is there's all the actions that can happen, which is supplying a collateral, borrowing, liquidating, paying back your loan, etc. Then there's how does Aave bookkeep all of that information? So it uses stuff like A tokens, so some rebasing tokens that it has. Now, how does it determine the interest rate and calculate that? Well, it uses that curve that everybody's seen, where the utilization goes up and then the interest rate goes up with it. So these are
Yeah, good idea. Let's switch over.
it's probably going to get distracting if that keeps happening. So I'm just going to use this. Hopefully.
Yeah, thanks. This is great.
Okay. Sometimes I find the audio quality out of this is not good, but hopefully I get an exception. So you have all of these facts that need to be presented to the reader, right? But you can't teach them all in parallel. It has to be taught in order. So you lay out all the facts and you say, what is the relationship between all of these facts? Because one thing I could just teach that, hey, today I'm going to talk about interest rates. Tomorrow I'm going to talk about liquidations. And the day after tomorrow, I'm going to talk about how governance influences everything, right? But if you are going through topics in a seemingly random order, then that increases the mental load of the reader. And the more you do that, the less they're going to like your writing. And it also goes against the objective, which is to help them to learn as quickly as possible. So two facts, there's a lot of relationship between two facts, but it generally boils down to one is a prerequisite of the other, or another is a co-requisite, or there's a circular dependency, or there's no relationship whatsoever. So as much as possible, you want to talk about the prerequisites first, right? And then after that, talk about the stuff that depended on them. But if you have a co-requisite, then you need to figure out if those two need to appear very close to each other, or you need to go back and forth between them. If you have a circular dependency, those are very annoying.
How do you handle something like that?
It takes a lot of editorial tweaking in order to figure out, are we introducing something that depended on the other topic or not? Those just, I don't have a good answer for it. Those, whenever we hit that, it always takes us more time to edit it.
Yeah, I can imagine. Maybe also a lot of diagrams just to explain these things are all linked, and then you can dig into each one, but at least you can see how they are all circularly linked.
Right. Yeah. A lot of it is, hey, telling the reader to suspend disbelief for a second. They just trust me, this is true. I'll explain why later, but just trust me, it's true. Now let's move on. And then now let's go back and figure out why I said what was true is correct. That's a very that's a comment that comes up a lot in our editorial process. I think you need to tell the reader to suspend disbelief. So that's one way to handle the circular dependency. So anyway, so you have the layout of all of that, and then you just, each of these turn it into a separate article, and you can, it looks kind of like a graph, right? And so, like if you topologically sort a graph, you can, a directed graph, it can put the input nodes at the beginning and the more dependent nodes at the end. So there's several valid topological sorts, so there's not always one correct answer. But it's going to end up being something like that at a high level. Of course, when you're actually writing it out and you try to teach something, you realize, oh, wait, there's actually a dependency that I missed. That always happens. It's not, I would say it would take an exceptionally smart person to get the knowledge graph perfect on their first try. That's not me. So we usually end up you usually end up having to create more chapters than you anticipated because, oh, that actually depends on this. This wasn't well taught. And then you can start regressing until you hit a point where, okay, I'm really sure that the reader ought to know this already. So that's how we create, that's how we structure our stuff. I'd say another factor that goes into it also depends on your target audience, is making sure that you keep them interested. If you're talking to mathematicians, they love abstract stuff. So that's, you can just load them up with theorems and things like that, but developers tend not to appreciate that. It's how can I actually use this information? So like I said, there's several valid topological sorts, but you might want to jump ahead a little bit and give some real examples so that people don't disengage, and they can because developers live in the real world and mathematicians don't. So you need to tie real world stuff in, otherwise you're creating dangling knowledge that doesn't connect to anything. So that is that's another thing that guides our editorial process a lot, just in terms of structuring it. And once you've got the, no, sorry, I'm probably gonna like talk for like infinite time here. Just stop me if I if I need to. So that's getting your table of contents correct, right? Then you have to want to make each of the individual chapters awesome. So what goes into that? Well, there's a lot of the first one is you want to be as simple as possible. So Einstein said everything should be as simple as possible, but not simpler. And that's maybe that's cliche, but it's very, very true, I would say. So you want to think about it. It's a good idea to write down the first thing that comes to your head. But I think a lot of mistake writers make is you might be climbing up a local optima with where you started. You have to be okay with just starting over and, hey, I'm going to present the information in a completely different way. And that's one of the more frustrating parts of writing, is that sometimes, you go to you seem like you're making progress and you realize, no, I actually am building on the wrong foundation. So one of my favorite examples of this, seeing this with Uniswap v3, everybody who teaches Uniswap v3, not everybody, but a lot of people, they like to start with real liquidity and virtual liquidity, which is, if that's your starting point, it's really darn hard to, it's very hard to build a foundation on that, because well, why do we care about virtual liquidity? Well, because that's how we care about the price. That's why we care about the price. Well, why do we care about real reserves? Well, because that's how much you can actually swap until you hit the next tick. Notice how.
So what's a swap? What's a tick? Yeah, there's no dependency.
Right.
No prerequisites there.
Yeah, there's so much dependencies on other things, right? So if you started here, then you probably just should stop and talk about these things instead. So that. That's one of the more painful processes of writing, is just like, hey, look, I think this article is too complicated. You have to start over. That's always, yeah.
And that must take so much time, but it's worth doing. So how would you order a Uniswap v3 very roughly?
Sure. Well, I mean, I can tell you roughly the order in which we're going to talk about it. So the first 6 chapters, we just talk about ticks and only ticks. How do you convert a tick to a price? How do the ticks relate to the fees? How are the ticks spaced?
Tough to grasp.
Yep.
And so everything comes from them. That's a good place to start. Oh, that's great.
Right. So that's why. So people sometimes need to see the same information from several angles before they really get it. So you can't really talk about ticks in just one chapter. It needs to be. You're basically getting a different projection from this high dimensional space down to our little space until you finally get what this thing is. So that's another teaching device, which is the way you train a machine learning model, is you give it data until it can see the patterns. Works with humans too, actually. Like if a dumb algorithm can learn things that way, then a smart human, it should work, right?
Yeah,
so so giving people different angles of the same thing, giving people enough to interpolate the underlying idea is a strategy a different strategy we use. So talk about ticks for a long time, and then from ticks you can talk about providing liquidity. What does that look like? How does that get calculated? And then from there, we talk about swaps. And after that, you basically talked about everything. I mean, you still have to talk about the Oracle, but at the end, that's really all there is to Uniswap v3 for at least the core contracts.
Yes.
So that's that was not originally what we started with. We were originally gonna focus more on, okay, if you know the price and the liquidity, you should be able to calculate the virtual reserves. That's the direction we started. So let's talk about what price is and what liquidity is, and then let's move to virtual reserves. But then
how do you get price through the ticks? Yeah.
Right. So that's so that is, but that seems very unmotivated. Like, why are we coming up with a much fancier definition for something that we already know from Uniswap v2, right? So that's how our knowledge graph of, or what we considered the ideal knowledge graph of Uniswap v3 to evolve. And yeah, so I guess that's how that played out.
That's cool. I love that you call it a knowledge graph. It's such a good way to.
Yeah, that's
not a course
not my
course
term.
structure.
Yeah.
It's a knowledge graph. That's great.
Yeah, I didn't make that up. I can't take credit for that. That's I don't know where I saw it first, but it's
that's cool. It's the first time I'm hearing it. That's awesome. Are you do you dive into hooks at all in the Uniswap book, or
we're not ever
consider doing a separate one?
Yeah.
That's V4, of course.
Right. Yeah. So we'll see. I mean, we might want to ask Uniswap Foundation for money on that. We'll see where that goes.
That would be so cool. I'm sure they'd be keen, because
but
V4 is massive. You can't read that repo in a day. I tried.
Right.
I got very overwhelmed.
It is. Yeah. Yeah. So we right now we don't have any explicit set plans to write about hooks, because we still need to finish the Uniswap v3 thing. Obviously, Uniswap v3 flows very naturally into v4, and a lot of people are writing about hooks right now. So I want to wait and see where
the re-entrancy.
Right. I want to maybe let the dust settle a little bit and see where are the actual needs in terms of content for that. And
yeah, that makes sense.
But yeah, to answer your question, it's not in the short term. We don't have plans for it.
Okay, yeah, fair. Also, hooks are very, they aren't used often. Like you said, there's not always like a context for them. But they are becoming quite ubiquitous. I'm working on some at the moment at Superform, and it's really cool. But there's so many articles, but they're all like no prerequisites, no postrequisites, just like a little snippet, and then I have to read the other ones from other articles. Yeah, cool.
Yeah.
How did you get into developer education? What's your background?
Sure. Well, I think I might have a knack for teaching in general, because I've been doing some variant of it as a teaching assistant or a tutor for like a long time, 18 years, 17 years on and off.
Oh, that's awesome.
Yeah. So that's one part. I think what really solidified Web3 developer education for me was I worked on a project that never launched in 2022. No, 2021, sorry. And that was when gas fees were crazy on Ethereum. And so a lot of effort went into how can I make the gas go as low as possible. And there was not a lot of information about the EVM back then. Nowadays, it's very easy to find, but back then, no. So after we decided, hey guys, we should just not launch and we'll close everything down, I spent the next month turning everything I learned into a Udemy course. So that's on gas optimization, and that became a bestseller in like 2 weeks or something like that. So yeah, thanks. So that created that was okay. Obviously, there's some luck involved, but maybe there's some alpha here too. Just in terms of this is something I could be good at. Because if you get success that quickly, then that's interesting, at least, right? So that's how I ended up going into Web3 education full time. Also, I had been writing on Medium for a long time, since I don't know, quite some time. And the articles I did on what's it called? On like Solidity, just in general, some gas optimization and whatever. Those did much better than my other articles.
Yeah.
So that
Okay.
was another signal that people are really hungry for this information.
That's really cool. Were you involved in the gas optimization book by RareSkills? I actually have it bookmarked.
Oh, thanks.
It's such a good book.
Yeah.
It's such a good resource.
I'm not. I mean, there were a total of 4 people who worked on it. So at most, I'm responsible for about 25% of it.
Okay, that's cool. And how does it work? Once you've made the knowledge graph, take separate chapters and then edit each other's and then edit the whole thing? Or do you have separate editors? What does that look like?
Yeah. Well, with the editors, we try to pick editors who we think are our target audience. Oh, sorry. The author is whoever is the author, right? But the people who review it, now part of working at RareSkills is there's an expectation that you're going to both write and review. So even if you're not the target audience, try to make yourself the target audience. And that's not super ideal, but we can't afford a massive team, so it is what it is. There's that. We do bring in some external reviewers just because they will have a fresh eye or something like that, or we think that they might have something interesting to contribute. And also, you sometimes just do need different viewpoints in order for things to get caught. So, for example, most people who are at least tangentially aware of Uniswap v3 knows that it uses square root price as how it tracks the price. That's for some reason very popular knowledge. So there was one chapter where we just offhandedly referred to that and didn't realize, we never actually introduced explicitly that Uniswap v3 uses square root price until someone, however it got caught, but all of the reviewers didn't catch that because they already knew that.
Yeah, everyone knows this, but not everyone does.
Right. Exactly. So even if it is common knowledge, you still need to explicitly talk about it in the book about Uniswap v3. So that was why. So that's why you need to have several people look at it, or even have the same person look at it with fresh eyes and space it out. So that's one thing that really slows down the editorial process. If you keep reviewing the same article same day every day of the week, then you're just not going to catch things. Your brain is just going to tune it out. So you have to put it down, work on something else, and come back to it. So that's always going to cause some kind of a increase in the production time.
Yeah, I can imagine, but that's really valuable to do. I
make makes a huge difference.
Music, and if I just work on one song, it becomes really bad. But if I leave it for a few weeks and come back, I notice all these things that were bad. Yeah, but it sucks to put something down.
But what genre of music do you produce?
I have some electronic albums out, and then I'm working on a jazz album with some friends at the moment. So a bit of everything.
Nice.
Wow, and then also record and mix other musicians. I love it. Yeah. And the boot camps, what's the structure of those? Are they called boot camps, or what do you call them? The courses?
Yeah, that's a good question. Boot camps, instructor-led cohorts.
Cohort the boot camp seems very small. Cohort can be.
Right. Well, we intentionally keep it small because one thing we don't want is if the instructor is just yapping for an hour straight, right? Then why don't he just record himself? We'll edit it, make it look very nice, and then just have people watch it. Right. There's no added value from that for the people, so that doesn't justify charging a price, or at least it doesn't justify the prices we're charging. So what we instead want is, what I've found is, like there's this thing, the Socratic method, where the teacher is asking the students the questions and then trying to get them to engage and kind of gauge where they're not understanding things. That is the most efficient method of teaching that I know of, and I've tried all of them a lot. It's way better than having fancy graphics that are tuned with 50 different people giving you feedback about how to make it amazing. Why? Because active learning versus passive learning, those are not terms I made up. Active learning will just beat passive learning every single time. It's way better.
And I guess
And then
if
if
it's
you
too
tune,
large of a group, you can't actually actively learn with each of them.
right?
Okay.
Yeah. So we really try to, so we cap it at 10 people because after that, it gets really awkward just speaking up in front of the class. Even though cameras are off and whatever, the people just feel weird about it. So you want it to be people to be more comfortable with each other. I mean, I think in a very perfect world, it would just be one-on-one for 30 minutes all the time with an instructor and one person who really knows what they're doing. But in order to really scale that, that's going to get quite expensive if you really want to have instructors who know what they're doing. We are super particular about who we hire. Like they have to have managed either a ton of money or they have a very senior position at an audit firm or something like that. You don't want just someone who knows some Solidity and is good at talking. I think that's or who has some charisma. That can leave people, oh, I had a good time in this class, but did you actually learn? That's really the outcome you want to optimize for. And you have to be, the only people who are really going to see what the person's not knowing is people who just know a ton and know it really, really well. So that's, so we're very particular about hiring people who have an amazing track record. So that is how we operate the boot camps, but the stuff we cover in the boot camps is available for free on our website. I think that's a common misconception. Some people say, oh, I love RareSkills, but it's too expensive. Just read the free stuff, it's there.
Okay. I thought
now,
it was it's just because you actively learn it with a professional who really knows.
Yes.
Wow.
Yeah. So I think 95% of people who are 95, maybe higher percent of our people who are using RareSkills should not pay us for anything. They should just read the content. Now, for people who, okay, I need to learn this quickly, or I'm a busy person and the amount of money you're charging is not a lot to me, but I want to, but I care about my time a lot. And maybe maybe I want some kind of a structured learning on top of
external pressure.
What's there. Then, yes, then those are the people who can who we really want to target with that. So that is, and then we want to keep the price somewhat high because the more people who come in, the more the higher our operations costs become. So that's I sell cheap courses on Udemy. It's a terrible business. It doesn't work unless you have really massive scale. And if you're just paying yourself, it's fine. But if you have a team, it's not going to work. And yeah, so that's how we structure the courses. Usually, the people who are signing up for, like, our Rust bootcamp costs $900. For people who are doing private audits, $900 is nothing.
Yeah.
So that's that's really the market that we're trying to address with the paid stuff.
There's no Rust book, or is there? Have I missed it?
No, we don't actually have. I guess that's an exception.
The one. That's
but we right. That one, okay. That's maybe that was a bad example, but
no,
you can learn Rust. You can learn Rust for free. There's the Rust. There's already a Rust book. There's a lot of tutorials on YouTube. That Rust course is actually a little bit different because it's taught more from a smart contract security angle. But obviously, part of it is teaching the syntax, but more of the emphasis is on reading Rust instead of writing it. Although you do need to write Rust, but it's more. It is audit oriented. Since that's a good chunk of our audience.
And where you can start auditing that, and I guess Solana stuff too.
Yes. So, but aside from Rust, so Solidity, all of our content is available for free. It's not all in one place, but it's separately inside of the books, and you can read it. In fact, there is some free content on our website that's not covered into the course, just because we don't have time to cover it. So, if anything, there's more content in the free stuff than there is in the paid stuff, just because we can't. There's only so many lectures you can have.
How long are the boot camps? Are they different per boot camp?
Yeah. So, well, we generally keep the Solidity ones we target an hour long. For zero knowledge, I try to keep them 45 minutes or less, just because people's brains really get fried if you go on for too long with that stuff.
Yeah.
For Rust, it's we're now experimenting with an hour-and-a-half format, just because it's a super interactive class. Whereas zero knowledge is a tad one way, because hey, here's a bunch of stuff that there's no way you could figure this out on your own, right? So the instructor will do more of the talking, but can still ask questions. Whereas Rust, you're talking to experienced people who already know how to code. So hey, what does it look like this code does?
Yes, that can be a lot more active.
So, and then because I mean, you can kind of guess what Rust does if you can't, even if you've never used it, right? So I mean, not all of the time. There's some weird syntax. What the heck is this? But like a lot of it is you can kind of guess what's going on already.
Yeah, my friends are Rust.
So that's
sometimes I peek over his head. I don't really know Rust syntax much, but sometimes I can be like, oh, that's doing this in the contract, or sometimes I'm like, okay, that's alien. But usually I can understand the logic. Yeah. That's cool. And then how many lectures are there in bootcamp on average in the boot camps?
It's 1 to 2. So for zero knowledge, we do 1 lecture and 1 office hour. So the lecture is where we're teaching the content, and the office hour is where people come in and ask questions. And we don't explicitly teach new content there unless people ask for it.
That must be most of the learning actually happens, that office hour.
Yeah. So it serves as a time of review, because sometimes you just need to see things explained to you more than one time, even if the explanations are perfect. That's just how it works sometimes.
Especially with CK.
Yeah, especially with CK. For the other ones, for Solidity, it depends, because we do teach some Solidity in a separate thing with base, the L2. So that one is structured as 2 classes per week and 2 reverse classes. So the reverse classes are like quizzes and whatnot, and the classes are actual lectures. But for another style that we teach Solidity at, like the one that you see on our website, it's you meet with the instructor once per lecture, and then depending on what week it is, you'll also have a code review of what you've written for 30 minutes. And for Rust, operates pretty similarly. 1 lecture, 1 code review, and except that you need to meet with the instructor every single week for the code review, because it's with Solidity, some of the projects are longer and it might take more than 1 week to do it. But with Rust, since it's an introductory thing, then the assignments are not long. I would say that's actually one important thing that I've learned that's counterintuitive. Project-based learning sounds awesome, but for someone who's new to a subject, it's not, because you write a bunch of code and you don't know if you're doing it right or wrong, and you could be enforcing bad habits. Now,
yeah, absolutely, with the bad habits, or with some hackathons I've done where there's not enough time for them to like learn their topic and then work on it, or like you just start the topic and they aren't like advanced enough, or tutorials I've done with other groups here in South Africa. They'll have a bug somewhere in what they did in the first day, and they don't realize. And then on the like second week, they're still stuck, and they don't realize it's from that first bug, and they just have been like creating technical debt for that whole time. And it's more frustrating than actually like rewarding. And you don't learn; you just give up.
Exactly. Yeah. So now, if you're on your own and there's no resource, then projects are fine. I'm not saying that they're bad; they're just not the best way to do it. In an ideal world, you work on a bunch of bite-sized exercises. When you're new to the subject, you work on a bunch of bite-sized exercises and get rapid feedback. So I'm thinking about this wrong because I got the wrong answer. So that's why we really emphasize a lot of puzzles, and we publish a lot of puzzles on our GitHub. We have stuff for learning assembly, gas optimization, security, just learning the Solidity language, writing SIRCOM for zero.
Oh, I'm so excited.
Yeah, we have to advertise that better, but just go to our GitHub and look for puzzles, and you'll find them.
Okay, cool.
That's actually terrible UX.
There's the capture flag book, but going on your GitHub to learn more assembly is my weekend plan now. Thank you.
Awesome, thanks. Yeah. Okay, so for the CTFs, we call them Solidity riddles, but everything will be called riddles, exercises, puzzles, or something like that. Usually puzzles.
Awesome.
So that is 100. That's where Huff puzzles, where we teach Huff too.
Oh yes, yes.
Huff puzzles, some alpha. That is the most. That is everyone's favorite week in the Solidity boot camp when they do the Huff puzzles. So I'm just moving everything over to doing as many puzzles as possible. Now, if you're teaching a more advanced person, then they don't need that rapid feedback, so you wouldn't structure it that way. But right, they can do a project, and they can actually learn from the project when they get the code reviewed. But yeah, I think active learning, like I said in the lectures, the teacher should just not be yammering the whole time. They need to be asking the student questions. When the students are learning on their own, it should, if they're new to the subject, it should be a puzzles, a short problems where they oriented thing where they get rapid feedback. Those two are the most highest bang for buck in terms of money and energy, or time and energy invested.
Yeah, that's awesome. That's really, really good.
Yeah, it took me about a year to learn that, but
yeah, I can imagine there's a lot of trial and error. Like you try a course this way or that way, and then you see what actually works. And maybe in your own learning, you see what works for you.
Mm-hmm.
Yeah.
Well, it's a little tricky because I can't make puzzles for myself to learn, because by the time I've made the puzzles, I already know the subject. So, but I would just say, what we try to do is we learn a new subject. You figure out what are all the thorn bushes you run into, and how can we help the next person not run into these thorn bushes. That's a very big part of teaching a new subject. Like, where did I get stuck? And then chances are someone else will get stuck on that same thing too. Now, if you're very motivated to go through the subject, then of course you're going to be trying out different things to validate your knowledge. But if you're only sort of motivated, then it's nice to have like, hey, here's some problems you can solve, because you have to be super motivated to think of problems you can solve and then hold yourself to actually solve them.
Absolutely.
Right. So so that's another thing where we try to lower the barrier to entry in terms of time invested and also the level of motivation.
Okay, yeah, that's cool. That makes sense. When you were learning ZK, you said it took you a year. What prompted you to get into it, and how did you teach it to yourself in that year to become so good to write such a cool book?
Oh, thanks. Okay, so I was very lucky because what I studied in grad school was adjacent to it. So that is a very, very big disclaimer that I think everybody should know, because it's not like, oh my gosh, I figured it out or whatever. I came in with a very...
Was it photography or was it abstract algebra?
It was computational theory. So
that's cool. Yes.
Yeah. So whereas ZK is trying to validate that a computation was executed correctly. Now it's very easy to describe that, casually, but what that precisely means is actually quite intricate. So luckily for me, I had already had a lot of adjacent knowledge to it. Obviously a big challenge is that everything written on it up to that point was either way too shallow or way too mathematical. Now, luckily, I could more or less work my way through the math. There was some stuff that I needed to really brush up on and learn. So pairings were a monster to learn. That was very hard. But that's how I figured out in retrospect. Okay, you don't want to actually learn the algorithm any more than you don't need to know the internals of a hash function. You just need to know what it does.
Yeah.
And so it could have been a lot faster, because I watched a lot of YouTube videos on anything related to pairing and tried to find any resource I can. When in reality, I realized I'm missing the forest for the trees. Okay, what are we even trying to accomplish with this pairing in the first place? That's why are we using it? What's the high level thing? That's what how I should have looked at it, but I didn't know that. So in terms of how I learned it, a lot of it was reading the academic papers, to be honest. There was this Medium series. It's linked on the ZK book. It's I thought he explained some stuff pretty well. Some other stuff didn't make sense to me, but it definitely helped clarify a few things. There were a ton of tutorials on going from R1CS to QAP already online, because Vitalik wrote a blog and then everybody copied it basically.
Oh yes.
But it was so hard to like, what's why are we even doing that? Why do we even have an R1CS, and why do we even have a QAP? Now, how a lot of people will talk about it is, it goes from QAP to linear PCP and whatever, but that's not actually the right way of thinking about it. One thing that helped me distill what was actually important is I read the Tornado Cache source code and tried to figure out like what's actually going on here, because my destination should be understanding what this source code is doing.
Yeah, that
kind of helps.
And how it gets there through, and how it actually applies the Groth 16. Nice.
Yeah. So the other part this is actually, I would say, the biggest part is the Groth 16 paper describes the algorithm fairly straightforwardly. Right, you can just write the math and say, okay, it's doing this. The big question is why, right? Like, why do we have this alpha and beta parameter? Why is it secure that we can use tau in this way and whatever? So I would say, so I think one thing that made the ZK book really good is I spent a lot of time trying to think, if I remove this, that means I should be able to break the protocol. So how can I create a false proof if I remove this feature of the algorithm? And then I just had to put on my white hat and figure it out. And like, oh, okay, I can create two proofs for the same thing, or I can create a proof when I don't actually know the answer if this isn't here. So that was, I would say that actually makes up the lion's share of how I came to really understand ZK as opposed to just like, I'm going to try to translate what the Groth 16 paper is saying. Because the Groth 16 paper doesn't contain any of that information. I'm guessing he assumes his readers can already know it or something like that.
Yeah, that's such a good thing.
So that's how I use that approach with code bases too. Like why is this logic here? For very audited code bases that we cover, then then you can kind of trust that it's there for a good reason. And anything that's heavily used in production, like bulletproofs or something like that, then you can generally trust that it's like this for a reason, and you need to figure out why. Now, if you're looking at a new code base, then you should not have that mindset. You should believe that there's bugs. So that is, I would say that's where the bulk of my time went in terms of where it came from. Like, okay, I can just recite the algorithm to you, but I don't know why it does that, versus this is why the algorithm is the way it is.
Thanks. That's such a good technique, because I sometimes read I try to read some zero knowledge papers, and they introduce all these, like, in one paragraph they'll introduce 4 new variables. I'm like, okay, but what are they? Who are they? What are they doing? Why are they here? And then I get overwhelmed and disparaged. But if I was to try to remove them one by one and see their purpose, that's a really good tip. Thank you.
Yeah, thanks.
Oh, thanks. This is really inspiring. I'm definitely going to check out your guys' GitHub for some puzzles and riddles. And hopefully we can have you back to do a zero knowledge deep dive if you're keen sometime.
Yeah, would love to.
Thank you.
All right.
Thank you so much.
Thanks. Appreciate it.